How much should we water the crops, and why does it matter? Water usage and farming are important issues in Australian industry. Even some seemingly simple aspects, such as how much should we water the crops, can require a lot of thought and planning. At huge cotton farms such as Cubbie Station in Queensland, this question is very important. Cotton is a very thirsty crop, so deciding how much water to use from the reserves and the local river system is a big deal. We can think about how adding irrigated water to the cotton plants changes how much cotton will grow. If we don't irrigate at all, then natural rainfall will allow a little cotton to grow. If we do irrigate, then more cotton will be produced. But if we irrigate too much, then the crops can flood and produce less. This is an easy idea to understand. You don't have to be an economist to get that. So how can we model our scenario with fancy, intelligent-sounding economics terms? The term we'll be using is marginal product, which relates to the total production. To model our cotton production, we'll place the number of megalitres of water on the x-axis and place the number of bales of cotton on the y-axis. For any production graph, we want to put the input on the x-axis and the output on the y-axis. For each added megalitre of water, we are going to plot how much cotton is produced. Our first point is at 1 bale of cotton with no irrigated water, as natural rainfall has watered the field. Then, as we add irrigated water, production increases to 2, then 4, then 5 bales of cotton. The fourth megalitre of water has reduced production down to 3 bales, then continues to drop down as we are overwatering the crops. This line then becomes our total product curve. From the total product curve, we can derive another curve that is very important in economics. This is called the marginal product curve, and it shows how much extra cotton is produced when 1 megalitre of water is added to the crops. Starting at 0, the marginal product curve increases to 1 unit because adding a megalitre of water has increased cotton production by 1 bale. Then the marginal product curve increases to 2 because the second megalitre of water has increased production by 2 bales of cotton. Then the third megalitre of water has only increased total production by 1 bale of cotton. So our marginal product curve drops down to 1 unit. At this point, we can see that adding more water will have a negative marginal product as the marginal product curve crosses the x-axis. You can see that at this point is also where the total production curve is at its peak. Beyond this point, adding more irrigated water is drowning the crops. So why are we so interested in marginal product when we look at how water should be used in cotton irrigation systems, such as Cubbie Station in Queensland? The marginal product curve can show us that at this point, adding irrigated water is effective because the marginal product is still increasing. At the peak of the marginal product curve, adding further irrigated water will then become less effective. When the marginal product curve crosses the x-axis, we need to stop watering because the crops are drowning. So in conclusion, if we irrigate up until the peak of the marginal product curve, we reach the most effective point which has used the input efficiently. Maximising the production's efficiency will keep the farmers, the manufacturers of cotton, and the consumers of cotton products happy. In economics, we like to start simple and develop ideas with more complexity as we analyse them. Our model has only looked at how irrigated water can affect the production of cotton. Other inputs could be modelled in a similar graph, such as labour and capital. Then changes in technology could also be accounted for, such as improved farming equipment or a genetically enhanced crop. We also haven't considered the price of cotton or the cost of water. These factors could alter which part of the marginal product curve becomes the most efficient. If we mix in all these variables, the answer to our question will be far more complex. Understanding marginal product is the first piece of the puzzle to start understanding not only how cotton farmers, but all businesses make their production decisions.